So my name is Dov Jacobson. I'm founder of GamesThatWork. And I'm learning how to use the interface. There we go. Okay, so I came to Atlanta. I started out making films about serious topics, like working for Carl Sagan, making the original Cosmos when I first got out of school 100,000 years ago. And then coming to Turner, and because it was exciting to take technology and do almost anything artistic with it. It was real exciting to be part of the video game industry starting out. And at Turner, we did anything, mostly entertainment, occasionally games that were entertaining and serious, like a game about Gettysburg. And Turner lasted for a while, and then it crashed like every other media company did. It crashed when people discovered when the internet came around, and people didn't have to buy a CD-ROM to learn, or to entertain themselves. A big part of what we made was just all this massive information on a disk. There was a bigger world, and it was more interesting. But for a while, we kept making similar kind of games as a company called Big Fun, and we did find that there was probably one of the biggest markets that existed were parents wanting to find content they didn't want their kid just hunting on the internet. They wanted to be able to put a disc in front of their child that had some meaning. So we made some dinosaur games for museums, things like that. And but it wasn't a terribly lucrative market for publishers, for the big publishers. And we really focus on games that have learning mission in the 90s, in 2004, and switched our name to GamesThatWork, and went to find the people who believed in it. And it turned out, since then we've done a lot of work, but at the first it was just the military. The military has always known that games are an effective way to teach. And over time, there's been interest among research organizations like the NIH, the NSF have done some supportive games, museums, things like that. But it's been very slow to be accepted in schools, despite its very obvious benefits. And also, the school market has a lot of complication that make it infeasible for a company like us that doesn't have a giant runway. I felt over time that really that the market that would fit us well would be a corporate market, where they can pretty easily quantify how much the learning is worth, and we could quantify how much better we could deliver the learning for a given price. And every damn year since we started with them, we do the military stuff, and in our plan that we wrote out, it would be, and we'll take this and we'll use it as proof in our corporate marketing. But it's been very hard to make that case. Although this sort of did. We did a military project with Boeing. Boeing is a huge company and has really the military part of it and the commercial aircraft are very different. But in doing the project with Boeing for the intelligence community, actually, that was an interesting project. It was all about teaching cognitive bias. It was, it sounds military. It sounds like it's going to be something simple like shooting. What the military does and the intelligence agencies do are really sophisticated psychological training. So that's exciting work. And we did a great job and got some sort of award that Boeing gives to its vendors that do well, which was we were able to finally go to a real corporation after trying this, going to a lot of other corporations, but going to one with some sort of credibility. And I don't even think, even with that we would have been able to sell them on the idea. Someone internally said that we should try games, and here's why. This is a tiny little section of the largest building on Earth, according to them, by volume, which is their factory in Everett, Washington. And in that factory, there's several production lines. This is the 767 production line. This arguably is the most complicated thing that's put together in an assembly line. There are 3 million parts in this airplane, this very complicated machine, on which people depend on for their lives, and it's going to cost a lot of money. It's a very demanding production line. But if you probably can't see, there's little red buttons everywhere, though, or big red buttons at strategic positions that say, if you see something dangerous happen, just press the button and stop the line. Everybody has the authority to stop the line. I don't think anybody's ever done it. Because when you stop that line, that's probably hundreds of thousands of dollars an hour, maybe more, in the cost of that delay. And everybody's very aware of the importance of that line moving. So there's 3 million individual parts that come through together here. That's not the first time those 3 million parts came together. The first time they came together was in a computer. Right? They don't sit there and figure it out. They don't get boxes of stuff and say, what are we going to do? Somebody builds it all in the computer. Not one person, hundreds of thousands of people in thousands of different companies all over the world are putting together the sub-assemblies and the assemblies and the installations. They have names for all the different, as parts start to aggregate into bigger parts. And those, like I said, are done all over the world. And the biggest problem that they have is that that's a line, too, that's easily stopped by, if one person stops, there's all these dependencies that are already stopped, and the development or the production of the game, of the plane, is delayed, and that has just as much cost. And they have a whole group of people whose job it is to keep the engineers fluent, keep them moving their plans, being able to do their work without error or hesitancy. And they found that what's stopping them is these 3 words. The greatest, every once in a while they have these coaches. They log all the engineers' concerns. Every ticket that they get, essentially, and then someone sat down and analyzed them and analyzed that these words, which seem really, have I been off mic before? I guess that these words, which are seem trivially easy, especially to a game developer, confuse people and stop them from working. Or either young people get stopped from working and ask for help. That's the good case. The older engineers get confused and use the wrong one, and consequently, there's an error that's much harder to undo. You can probably read these words and you can get an idea what they mean. To make an airplane, this describes a part that goes into an airplane. Somewhere there's a document that says what it looks like. That document's like a 3D model, typically, but it's also maybe it's the audit trail procurement. It's it's the lot number. There's actually the testing that has to be done on it. There's a lot of documents that describe different parts of the part, which are unified by the reference. The reference says, okay, here's all the documents that define a part. And that part doesn't exist just once, so obviously it's all over the airplane. So there's 3 million parts are all instances. Every one of them is an instance that points back to a reference, and that points out to a bunch of documents. That's all. That's the only thing. They just, it's like, you need a game that does this? But it turns out they did. Because the more they explained it to us, the more confused we got. They brought us to Everett, and they explained it to us, and they kept explaining it. And it's like, it got more and more incomprehensible, because to them it was all the buttons you have to press. They never took the big picture. It was always, if you're doing this set of operations, be sure you do it this way with that particular interface button. And and so they put out an RF. They decided that they wanted a game to see maybe this idea that's so simple, which they of course had already tried, training programs that, where lectures typically, or they had a whole set of manuals that you'd read to learn what these words meant. And maybe because it was relatively simple concepts, and maybe because nothing else was working, they decided to try a game with the idea that maybe other games would be also useful in other parts of their training. And it came with a game design. Or we didn't have to do anything, just implement their design. Their design was you would be a factory worker, and boxes would come down the assembly line, and you would have to say, is it an instance, or you would be told to do something, and to do it, you'd have to know which of the three words to pick. That's all you were doing, is picking those three words. But it was still like way down at the interface level of at the task of actually doing the next step, not thinking about how it works or understanding it. And since we'd already worked for Boeing, I started calling around to people that in Boeing who are friends, and said, what do these people want? And they said they want you to do it cheap. They're going, but do it cheap so that you can get in with Boeing, because it's a great customer to have. And so I came up with what I was, depressingly cheap bid for something that took 10 years to finally get it, in front of the people. But I also said, well, what I'll do is I'll do a slightly better version of this. In the cheap bid, we'll do a perfect job of this stupid game. And it'll be great, and it'll be very professional, and it'll be even a little funny. No, it wouldn't even be funny. It'll be just exactly what you do. But for the mid-level, where you make it like a game that you might want to play, where there's like interesting stuff happening, it's funny, and it's all kinds of cool stuff, that's a mid-price. And then to make the mid-price look cheap, here's the crazy high price. The crazy high price is I'm sorry. The mid-price was, here's a better game. We actually designed the game and pitched the game. I don't remember right now what that was. But the highest price was, we're not going to give you any game at all. Design now. And it cost 4 times as much and took twice as long as the cheap one. And it requires you to work on it for every week for 6 months. As opposed to this, you just walk away and you get it, and you can't talk to us about it. And again, it was to make the middle one look reasonable by putting extreme things on either side. But they picked the extreme one. They picked the ridiculously expensive one. Thank God. But they meant it. They took me seriously. Because, at one point I wrote this one line that my wife said, don't ever put that in there. And she was right, which is, we're not telling you what the game is, but we promise that we won't stop till it's perfect, till you're happy with it. Which they really exercised. So it turned out to be the right price. It wasn't neither too high nor too low. But they wanted the experience of working on it every week. They wanted to learn from it. And at the end, I'm like, okay, we learned. You love it, and now you're going to test it when you come back. Like, we can do another one, right? They said, well, you proved that games work. Now we can work with any game company. Wow, man, we proved that we did a good job. But so they brought us to Everett, and now we have this relationship where they brought 7 or 8 people to the table, and we had 4 people. And so these big face-to-face meetings. Wait a second. Sorry. What this game wanted to do was test. I forgot this important part. Not only was it a dumb game, the dumbest thing about it is all it did was test. If you got it wrong, you lost the point. That you just had to score. And at the end, it said, now you go to the manual and you learn all the things you got wrong. And maybe it would even list what those things were. But all it was doing was assessment. And at the same time, we got this cool invitation to come to the White House to discuss games with these other select game developers. And, whoops, there, I have to have my augmented reality version. Yeah, the real reality, it was a really nice room, but there was no There are no, even, I promised Jesse Biden or better, but we didn't even get Biden. We got nobody, just a bunch of other game developers and bureaucrats. And with the well, education government people. But what they wanted was the same thing. They said, how can games make assessment better? And to me, um, that was like, let's just make the really worst part of education better, of classroom education, which is, you instruct, then you go home and you exercise, then you instruct during the day, and you go home and exercise. This old model, and that assessment, something happens at the end, it's distinct from the other two phases. And sure, but that's not what a game does. What a game does is those three things are really intimately involved. That this, you learn to do something as you're doing it, and you're being assessed as you're doing it too, and then those feed on themselves. And so that was the mid level. The mid level included what I called like just-in-time instruction, so that when they screwed up, at least they found out what they were supposed to do, instead of being at the very end after they'd forgotten all the things they'd done to go read a manual that demonstrably didn't work. Otherwise, we wouldn't be there. So we began this process of understanding what was going on in these engineers' heads. That was the problem. So it's somewhere between what's on the head, in the head, and what's on the screen, where it was getting tangled up. And in particular, and there are a lot of different ways, and we laid them all out because we wanted to keep coming back and making more and more games, and I still hope we can. But this one, we wanted to put a box around what we were going to actually teach, and we were teaching data structure, how they're going to take all that data about parts and build it into a reasonable, repeatable, communicatable form. And the steps here in trying to go between the abstract concept in your head to the very concrete buttonology is what they refer to that as. Which buttons do I actually press in the interface to get my plans, into it? So this data structure, and within data structure, it's the active instantiation, taking one piece of master data, understanding the difference between the master description and all the instances of it in the world. And it's not just, even within parts, you need to keep track of like different manufacturers of the same part, things like that. We didn't even deal with that. But once you understand the idea of instantiation, then there's things I want to do. Like I want to make a copy, or I want to change the reference. I want this part to point to updated part, but I don't want to go change all those parts in the, there's different operations I need to do. And then once you understand what the operations are that you want to do, then you can worry about the buttons that you press, because it follows from that. And they taught entirely the other way up. You have to press these buttons, and here's why. And so this is the part that we thought was interesting. What do you want to do? What kind of data structure are you building in the abstract, not specifically what buttons you press? This is the part they liked. They have classes where they teach the buttons. When they tried to teach us what this was, we went to 2 days of button school. That just made us pull our hair out, because they would confuse themselves as well as us. Because they would say, well, this is how you do it, except in this case, which is true except in all these cases, and then you're down this rabbit hole and you lost track of what you were trying to do, what you're trying to put together. So we said, we're not trying to replace your instructors, because they're sitting at the table with us, and they have this job they like. We're trying to make their job easier. We're trying to create a game that will prepare people when they enter the instruction class to have a sense of what it is that they want to do, and you can teach them how to do it. So we wanted to separate why from how. And the compromise that we came up with, or the plan that we came up with, sitting together, is that we would make this game and prepare people for the class. And the way we would do it is that we would create a problem in the game that you would solve in the game. And we would take the same problem, the same models, the same models, and have you solve it again, now using, Innovia is the name of the software that they're teaching. It's a giant, what do they call it? Product lifecycle management, data management software for engineers. Their site license is like literally $1 billion site license. It's big ass software. But we will take our silly world and put it into your real tool. They'll have done it already in the silly world. Now they'll be able to do it in the tool. Okay. So what kind of, so I don't know, maybe we'll make a game where you're like playing with little icons and you're aggregating them, and then you're making something that's built out of multiple icons. Or maybe we'll make some sort of puzzle game, or maybe it's a game where you're switching that's a more complicated game that the puzzles are pieces, but you can change them all at once by changing what the references are. I'm going to go through these crazy ideas as fast as I can. Or it's a maze, and to take every step in the maze, you have to go through, you have to understand, you build little, I'm not sure I ever understood this point particularly, but the steps in the maze require you to solve engineering, this data problem of instantiation. Or maybe you just build silly planes in a baby version of the Innovia software. So we dumb it down, and we build a plane that's named after the car that he drove, which I thought, the boss drove, which I thought would work. But okay, so we threw all these ideas, and a lot more, or we'd take a game that works, that people love, and start building in that, and we, superimpose the data concepts in Innovia on Minecraft. Or it's some sort of team-based game, and it's the cooperation and the competition between the teams that is going to motivate you to learn these different words better, and really to take quizzes faster than the other members of the team. Maybe that's an effective dynamic. I don't know if it's a great learning game. Of all that stuff, and there was a lot more. This is the one that they liked. They don't like the maze game. What they liked, the only thing they responded to was this little character that in the hotel room in the middle of the night, I stole from the internet nowhere. It's like they kept coming back to this Martian. Okay, we have agreement. It's a game that has a Martian in it. And it was good. It was something we could work with. Only we didn't own the rights to this particular Martian. But he ended up being that Martian, which maybe is a little better anyway. And I'm going to make sure I can play, I think. Oh, I don't know. I hope so.
Let me show you around. Hi, I'm Martin, the Part Martian. We have parts for every vehicle built on Mars. Let me show you around.
So that's the concept. We'll build a parts warehouse. Sorry, I just have to find the forward button. That looks back. Oh, okay. So we'll give you parts, we'll give you access to parts in Mars. We'll be making it was really important that we don't make real airplanes, because these guys are aeronautic engineers. If they were even slightly realistic, all they'd focus on is how unrealistic they are. And the more realistic is, the more it's an uncanny valley, although not in visual sense, in engineering sense. So we wanted to make sure that our planes were absolutely unflyable, that it was a fictional cartoon world. But then we got into an argument. I love. If I had been born later, I would have loved Minecraft, but I loved Lego. I was even born before Lego. I loved Lincoln Logs and Rector Set. I loved to build stuff. That's how I learned to make things, was by building things out of little tiny blocks. Other people didn't feel that way, that we shouldn't be making stuff. We should take things apart. And they said, no, that's not how I learned. I learned by taking some, thing and getting out the screwdriver and breaking a bunch of them, and sometimes putting them back together. And that's how. And it was a kind of irreconcilable. Well, there's ways to reconcile that argument, like rank. I could pull rank, but that isn't necessarily the best answer. Although that was my first desire. Um,
Was the argument with the client or just internal with the dev team?
it was with the dev team, and we brought it back to the client. So what we did, and we didn't stop at the client because we knew we would get the answer from the boss there, just like I would want to do in my group. Instead, we prepared a test for them to bring to their engineers. It was a little flash thing to play with to see which they preferred, and it was unequivocal. They all preferred to analyze, to take things apart. And so it became clear that what we'd have to do is not a game about taking the parts and building cool things. It's about bringing broken things and modifying and fixing them, or upgrading, planes. So that helped a lot, because otherwise we would have, if it had been up to me, we would have made the wrong game. But I still felt, well, that I needed to keep some sense of that you're building. so I got this to keep this much. We take a product, and you find all the instances in it using the product tool. We named all the tools after the same equivalent tools in Innovia. And the product tool is fed by parts out of the part tool, and then all the documents are coming to feed that. This is the only thing I get to keep from my desire to be constructive rather than analytic, which is the flow. In the end, yeah, you're going to learn how, but in the end, you're going to learn that things flow from ideas to reality, not the other way around. Well, if you speak Hebrew, you won't learn that because you'll think of it flow the other way, or Arabic. But us as Americans, we always think of flow going that way. So we built up the world, but we built a world where ideas turn into things. 'Cause they did. And then that's the great database of ideas. And then it became a matter of trying to create examples. And we did what we always do, which is create. They called them. This is the word I learned from them, was twizbats. Do you guys know what that means? The student. It should be zwabat, but the student will be able to, and fill in the blank. And they do. And they say, well, the student will be able to push this button to get this result, or the student will be able to answer this question. So they identified the learnings in terms of twizbats. We tried to build schemas, which is a different way to look at learning, which is to say you build an idea, and then on top of that you can scaffold other ideas that are more interesting and complex, and eventually you build this model in your head, this set of schema that. So instead of compromising, we had kind of ended up doing both. We wanted to make sure the conceptual parts in there. They wanted to make sure that they understood, the actual steps. And then we broke down into five examples of these each situations where people would come in and illustrate the problem by, actually, what is it? Maybe I can go through them quickly. This is the simplest one where this guy's supposed to be a skater. He really doesn't look like it. He looks like a British boarding school student. But this was just identify what part is. He comes with a broken part, you replace it, period. Here, well, what about has one dog, and then the dog has babies, and all the baby dogs need seats. So so you have to learn how to take one part that's in the world, find what the references for it, and then duplicate it in the world. And it's really important to know the difference between right and left. Parts are right-handed or left-handed. If you just duplicate the part and put the engine on the other side, it's facing the wrong way, and they spin in circles. Um, and then, this guy with three heads. Here it got really hairy, where you actually had complicated parts. You had to switch underneath them what the definitions of what the documents in the definition were. Um, this is where, yeah, we really got to the last level of detail of the depth that we chose to teach. In other words, okay, so they one guy wants a flag that's got his icon on it. One of the heads of the same guy, and then another head from the same guy wants his icon on his flag, so you have to go and duplicate that part, but then create a different image on it through one of the documents. And then finally, we want to do everything at once. So we had asymmetry because the female was much bigger than the guy. It was out of balance, and you had to solve that. There was other things in here. This one killed us. This is stupid for me to say. Because I wanted it to be asymmetrical, and I thought, well, a couple that's poorly balanced would be a good way to do that. But I didn't think, and I didn't realize within Boeing there's all kinds of politics, and at one point they invited somebody who really didn't want us to be there to be part of somebody couldn't make it, and he sent someone who really didn't want us to be there, and this was a politically incorrect thing to do, which is to make a heavy female. And it was incorrect because we tried a lot of, I kind of came back and said, well, okay, she's heavier, but she's buff. We made her, like really fit and larger. I thought actually it would be more creepy to have a big guy fighting with a little woman. I thought that would feel worse. But it would have. So we couldn't do that either, right? We had to end up rethinking it, and really the resistance was very useful, in that it ended up being funnier and more fun than that. We ended up with a big, huge guy who's like really pathetically in love with this tiny little engineer wife of his. You'll see them at the end. And then we had to deal with, so we straightened out the examples, and then we had to deal with trying to create a dumbed down version of their software. And we didn't want, and first we had things that looked kind of like software with buttons and stuff and text, and we really didn't want that. We wanted to be we wanted the tools to form a diagram of the way we wanted you to think about what you're doing. So that's much more, yeah, well, and first we made it kind of, this will be cool and steampunky and, fun, like everything will be fun shapes, and we did all that in the little gray one that's in this slide is we screwed up with trying it again, the slide that we made for them, which is, instead of making them complicated, they're going to be really as iconic as diagrammatic as possible and still look relatively a little bit real. And there's details of how to make that work, and I just keep everything in a straight line so it's really clear the flow of ideas. But even still, we'd fight over it. Like, okay, well, you break the link between two ideas. What's the best way to do it? And I thought, well, it'd be really clear if the middle one is my idea. The line is no longer straight. You can really clearly see how it's slightly offset, and there's no connectors anymore. And someone else said, well, the connectors should still be there and hang. And someone else said, well, just put a barrier between them. So again, we got into a lot of communication, design questions, but they all came down to which communicates the idea better. And we didn't, we told them they were going to get the deluxe version of our development process, and they did. So we would test these, and we would go. This is 17 Boeing engineers being. We built all the different interfaces in somewhat simple way, and then tested them for which is the fastest to use. The first time you do it, and the second time, and the third time, and which is more accurate? How many errors do you make versus how long does it take? And you can see which is less. The blue. Blue is clearly it's more accurate, and it's more accurate. It's way more accurate in the beginning, and it becomes less important over practice. But we want it to be things that are obvious right away, not on the third time. And the same thing with speed. The speed doesn't matter too much after you learn it, but you clearly learned the blue one faster. You were faster on the blue one. And we thought, this is great. We can get really good answers, but it took 17 Boeing engineers to come up with that answer. And the Boeing engineer, I don't know how much they make, but they make a lot. And 17, and that was the bottom. Getting them to spend 20 minutes doing this was minor compared to getting their bosses to assign them to do it, to get the people to to move the the assignments around through the company to make it happen. It was an expensive process. And also, of course, took 3 days to get an answer from the time that we were ready to run the test. And that was too expensive for everybody. Too much time for us, too much money for them. Well, they didn't complain, but we knew we couldn't go back to the well a lot. So what we did is we went to Mechanical Turk. You guys know Mechanical Turk? Yeah? It's a way to buy commodity labor. Pretty unknown people to do any task you can do on the screen run by Amazon. But we didn't know that Mechanical Turk people would be a good proxy for either. Very little about them that you can rely on, unless you pay a lot of money. But the beauty part is very cheap. Instead of I don't know, maybe $800 for a test, it was $30 or $40 for a test. Instead of 3 days, it was an hour and a half before you had the answer to. You sit around and argue, you make the test, and by the time you're still arguing when the test results come back. So that's great, especially if you're right, which I rarely was. So we ran the same test through the Boeing engineers and the Mechanical Turk people, and the Mechanical Turk people were better than the Boeing engineers at everything. But we explained that that's okay because they're being paid by the piece. They were being, they had an accurate incentive. The better they did, they got paid. And also, these guys, all they did was test. I mean, that's what people use Mechanical Turk for a lot, is to test interfaces. And they only get paid by the piece, so they're really good at doing interfaces fast. And that Boeing should feel good about that. They did almost as good as those. I don't know who they are. High school kids. I actually don't know who they are. But we could use the results. It's not so much that it was exactly the same. It's that with a little finagling, you got the same relative answers, the same winners. So it didn't matter that the scale was a little off. So we had a world. They always wanted to have this sense of progress through the world, which I thought was a really good thing. A map. So we had these 3 worlds, these 5 worlds. Each one taught one thing. It was a nice little unit. And the next level of testing that we did is that we sent this really broken game that you had to push through by hand and explain what was going on a lot of times, embarrassing condition, to Washington with 2 of our top developers who could speak confidently that it would be fine in the end, but that for now that we wanted to test that and that we could tell the person what they were supposed to be seeing and move them through the game. And we learned more. We learned a tremendous amount by bringing. It was almost like a tabletop game. It was a broken game that you had to. Well, it was just an incomplete game that you had to. Someone had to be the Wizard of Oz behind the curtain, moving the game forward, and we learned that you couldn't go through the 5 steps and learn what you wanted. They came back with 15 steps, so that yes, we're not going to build more content because believe me, that was the 5 different worlds was enough content. but we would go and have different problems in those worlds. We'd break them up into these 15 steps. And in fact, that we had to even go into the Tripjack's world first to learn a little bit of something that only he could teach before we could go back into the other world. So that was the most valuable testing of all, is this formative testing long before the game was ready. And then also the structure made it pretty easy to create documents, simple, clear documents that we could share with Boeing every week to let them know where they stood, where we all stood in terms of the progress moving forward. It gave us, a language of, it broke things down in a nice way, so that we never lost their confidence, which was important. And we did a lot of things wrong, but we had, the process had control. They did one thing that really right that I would have done wrong. They wanted to prove that games worked. Oh no, they did wrong too. We just ended up with the right thing, and they. So their way to do it was, well, we'll pick something very narrow, these 3 words, and we'll do something very simple, and that was that original game they gave us, and it's really too small. It wouldn't have shown anything interesting. It would have shown that it's more entertaining to do a game than to do assessment through a game than some other way, but that's not the value of the game at all. It's a very small value. And we stopped selling games are fun 10 years ago. That's the wrong attitude, because fun isn't worth much. What we sell is games change people's behavior much more than other forms of education. And changes in behavior are worth a lot. They don't have to entertain these guys. They work for them. They're doing it on company time. It doesn't have to be fun, but it has to change their behavior. That they can't care about. Of course, if it were me, I would say, let's make a game that teaches everything and teaches all the way. And we'll make a great game. In fact, I even designed the scope of the game, not the actual game, but here's all the things that we could teach, and here's how we can teach them. It's only going to take 3 years. And only 3 years, it's nothing. Of Boeing pay, that'd be great. It would have worked, except by the time it was done, if it's anything like anything any other project like that, it would work at the end, and nobody that I'd originally commissioned it would still be working for the company. They'd all be in a different job. And I'd bring it to them, and there'd be nobody to say, great, it's ready. If they even would have that patience, which they rarely would. But every single time, then the game gets too long, the life cycle of your client isn't that long. So that would have been my mistake, which I wasn't allowed to make. If we'd tried to teach too much, instead of just teach those 3 words, well, it took a long time to make those characters worth watching. It's work, it's time, and animating them, fixing them, and voicing them. And we would have been a content development company, not study the learning problem. And we would have been focused on making great content, which would be fun, but wouldn't make a game that would make them want to make more games. Because it would be expensive, and it wouldn't teach people. Oh, sorry. Oh, I ended up with the sweet spot. The sweet spot is to make a game where the focus is very narrow, 3 words, but goes all the way down, that we do all that analysis, that we do all that testing, that we really look at what it means on those 3 words, and turned out to be a better part of a year. And took tons and tons of their time as well as our time. That's actually the end. I have 3 videos. If you want to watch the videos that we came up with, they're kind of fun. But so this is the real simple level where you're just learning to replace a broken part. This is the introduction. This is a guy coming in and stating the problem for each of these.
Dude, can you hook me up with a couple more skags like this one? I only got one skag now. When I hit a gnarly old wave, I can't keep her on an even keel. 3 skagaroonies would give me way better balance.
Okay, I'm sorry, this is a little later when you're actually duplicating parts. Obviously, they're live.
Is a skag an official Boeing term, or was that just something?
It's official, it's a surfing term. And this character's name is Goofyfoot, and turns out Goofyfoot is a way you can surf backwards, your feet backwards. And the one guy who wanted to kill our project was a surfer, and he surfed Goofyfoot, and he that got him over on us. But it was a total accident. Yes. Yeah, now we get along great. I just Goofyfoot is a fun name. Okay.
I want a special seat designated for doggies. I only buy the best parts for my cruiser. Money is no object. Each of my sweeties needs her own doggy seat.
So, this is the one where we put on we put the wing on backward, or actually the engine on backward. There's that. And this is Trip Jacks, is Jack Clubs, Jack Spade, and Jack what else?
With a white beater.
Yes, with a white beater with the 3 necks. Oh, a room in the neck for 3.
Incoming! I'm tired of my pirate flag. My name is Jack Hearts. I saw someone flying a red flag with a heart. I want that flag.
Oh, the heart flag? We sell a lot of those. To 10-year-old girls.
So the first version of Trip Jacks had 3 cigarettes. No, they had 1 cigarette. They kept sharing the cigarette. That was worse than the girl, the big girl. And the beer in his hand turned into the big soda. It's Boeing. Yeah, Boeing, you're not even allowed to smoke at home. Boeing. Really? I believe so, yes. Is that correct? Yeah, I know you can't anywhere in Boeing. You're outside at a parking lot. I'm pretty sure not at home. And then finally we have Thistle and Thorn.
Ooh, we're way out of balance.
Nah, it's only a little tilted. I want to make sure you're always comfortable on the love seat.
Thank you.
So I'm getting you your own cup holder.
Oh.
I want a matching cup holder on the other side. We'll have a match set. That is a sweet cup holder.
Thanks.
But it's only a cup holder. Let's be serious about our love seat.
I knew it.
I'm getting us a totally awesome red flag with the big heart. Because heart means love. Totally awesome! But we can do better. With more hearts. Ooh, and a heart-shaped flag. And a giant heart on top of the flagpole. Oh, this is so perfect. Let's go try it out.
Well, great. The important things are set. Now let's see about our little weight distribution problem. We need a more powerful anti-grav unit on the left side. We need at least 185 kilograms of anti-gravity.
So these are so we're now waiting for Boeing to test whether, how well it works, whether people learn from it, which is only going to take them a year and a half. I now realize it's going to take a year and a half. No kidding, because they're a union shop. They many reasons, but for example, they're union. They're not union tells them they don't have to play games on company time, and they're training. The union contract negotiates what training they're allowed to already be subjected to, and this doesn't happen to be in there. It's just complicated, real complicated. Okay, so I don't know if there's any questions or if we run past the time or.
You're okay on time.
Okay.
So, what is the demographic of these engineers?
They're predominantly male, but they're not all male. They're all different ages. The ones that they believe they're addressing are pretty recently out of college. That's who they made this for. I'd like to, but they have the problem even with older engineers. So I'm hoping that it percolates up.
So, what are they going to do to evaluate whether or not this is effective?
What we've asked them to do is to take their Innovia train. It's called Innovia Essentials. Their first level class. So this is made to be the preview for it. Test with ideally a randomized match control set. That'd be the best. But at least just one class that has and one class that doesn't, and evaluate whether they've learned more at the end, and hopefully whether they 6 months later, whether those ideas are more secure in their heads. And we hoped to be really involved in that, and we have not really been part of that. Again, that was a different group, the people who evaluated, a group that we were not particularly close with during the production, and maybe rightfully they don't want us to be really involved in the evaluation. We have a bit of bias.
And that Innovia system, is that something that is used by other aircraft manufacturers?
Mm-hmm.
Automobile manufacturers? Is it widely used in manufacturing?
There's like 3 of these in the world. There's 3. They have 2 big competitors. It's a company in France, surprisingly. And like I said, Boeing's license is $1 billion. Boeing's the biggest licensee, but it's pretty big in the aircraft industry. I think Fokker uses it, and so it was originally an aircraft company that turned into a software company. DeGrasse, I think it's called. But but it is also used. I think Caterpillar uses them too. I'm pretty sure. So it's used in manufacturing big things, especially vehicles. So I would love to hope that we could take this out of Boeing.
I mean, there's a lot of manufacturing in the Southeast, and apparently this sort of training problem within manufacturing is a big issue, and not even with the not college educated, sort of VOTEC
Mm-hmm.
students that are coming in, and a lot of them are young, and I think it's hard for them to just train manuals.
Yeah. I agree.
Apparently, I mean, this is, doing the game-based training is a big thing for especially the younger demographic, not just in manufacturing, but I'm aware of a couple of different sort of fast food restaurants and things
Mhm.
that have sort of a game-based training system.
Yeah. Part of it is just general literacy, frankly, or low-level literacy, and
But so many of
but-
the sort of younger employees do see a train man as just a wall of text.
Mhm.
They do not want to.
Me too.
Yeah, we're all guilty.
Yeah. But it goes beyond that. It's easier to understand something that's in pictures, but you could give them a comic book and they get the same value, or anime or a YouTube video, right? You don't have to be able to read; just watch a YouTube video. A game has much more than that. It has that cycle of exercising, which obviously a simple instruction doesn't have, and it has that built-in assessment. It has the ability to not waste your time learning things you already know how to do by trying out and see if you know how to do it before it bothers to tell you. It's pretty important. It can, break it into small bits so that the assessment, some small element and the remediation of that, the teaching of that happen together, and then you go on to other ideas rather than big chunks.
So in your system, when the engineer, sort of fails to do the right thing.
Mm-hmm. Okay, yeah, I didn't really go through that.
So you have some sort of a little, then immediately jumps to some sort of tutorial, or do they just try again?
There's a little bit of trying again. We kind of wanted to push things forward. When you fail, there's like I say, a few places that are meant to be kind of sandboxy, but not a lot. These are more like puzzles that have a correct answer, and we look at the particular failure that you're doing, whether if you're using the wrong. There's different levels of failure, but the ones that we want to fix right away. In the actual game, you're in the big shop with Martin, the Martian character, and with the customer, and the customer's fetching that it's not ready, but Martin is telling you when you do the wrong thing. Sometimes, even when you pick up the right tool or the wrong tool before you use it.
Okay, so Martin is there acting sort of as a mentor.
Absolutely, as a mentor.
Okay.
Yeah. Yeah.
Kind of want to ask about other types of instructional design. So on your chart, I suppose would be where you were comparing like simple game, deep game, narrow scope to like a broader scope.
Uh-huh.
I understood that part. However, there's like obviously like many different ways to approach an instructional technology. So my question was, how does this particular one, like what are the strengths of this particular one versus other ones? Because there's a lot out there, and like they all have like varying levels of effectiveness. I just wondering what you personally thought your strengths were in this.
I guess what I was trying to show there isn't so much that this taught better, but that strategically it fit the customer's patience and needs better. The customer wanted to find out if games would work. They'd be very happy to find out the games don't do much. They could check it off their list, tell the guy who is the proponent of that to shut up and move on to something else, and they would, and they'd go on doing what they do the next kind of computer-based training. So we had to make a dramatic difference, but they didn't have the patience or really the unlimited budget to do more than one little bit really well. So that's what I was trying to show there. As far as different instructional designs, this is one way to do it. It's the best that we could come up with, and I tried to show the decision-making process of why we ended up here. But obviously we could have made similar decisions and ended up with a very different game that may have done better or as good or worse. It is. But yeah, what we tried to do is make sure that we were questioning our answers, either ourselves or our customer, or better yet, the end user, that we were getting direction from there rather than from our own aesthetic or desire to make stuff. Although the cartoon characters, because we want to make cartoon characters. That had to be there. Anything else? No? Well, thanks a lot for coming.